果你现在已经念不下去，因为刚刚知道说我们连续上了4堂课5堂嘛，已经快撑不下去，没关系，可以离开，没关系。好，可能安静的离开。OK。I think that I'm generally first time to do the summaries across is because the scores from the quest 2, quest 1 or your middle exam. I think I'm very nervous about you. I think I don't want to modify the score by myself. I hope you can get the pass score by yourself and without any modified original score. Okay. So I hope I can give you more details and concept, and you must get the score by yourself. I hope. So I think that your final exam will start from this chapter, imperfection in solids. Okay. So in this part, you need to know some. I think that quickly to review, and you must answer this question by yourself. Even if you can take picture and go back to answer Gemini and Copilot and let the AI tool to give you some exercise problems, whatever the single elective problems or some Q&A problems, okay, whatever. If you do it and you can, I promise you can get the score. Okay. So I'm so I will find some of the students that get a 0 score in your quiz 2. I think the student who gets the 0 scores, I think it meets a very hard problem about the time arrangement by himself or herself. Okay, not about me. Okay, it's because generally in your course they will get the more than I think 95 or 97 scores. Okay, about your classmates. Okay, so first one is the solid state solution. You must know what is the solid solution and how the solid solution occurs, and there are things that 2 steps of the solidation process. Okay. Okay, so first one nuclear and crystal growing and the grid structure. Okay. And the second one is you need to know what is called the grain boundary. Okay, the grain boundary. What is called the grain boundary, and why the grain boundary is such a very important in the material. And the grain can be equal size and Coulomb. Okay, what is equal axial? Equal axial is seems like the outside surface, and how the equal axial grain size perform, or how the Coulomb grain performs in during the solidification process. Okay. Imperfection in solids can be seen as the 3 different types. Okay, the first one is point defect. Okay, I think so. We have it. You will be. You will. I think so. In the previous course, you have learned how to define and draw the pictures about the point defect. And later, you need to understand what is called the light defect, and the dislocation can be seen as light defect, and what is the dislocation. And the grain boundary, why the grain boundary can be seen as an area defect, and also you can know that if I asking you what is the in the following point, which is area defect, you must choose the grain boundary by yourself. OK， 就是说，这里跟大家讲一件事情，就是，这里会怎么考选择题啊？你要知道 light defect 对应到什么性东西，然后是插排对应到是 light defect。OK。我还讲英文好一点，你知道吗？因为 I think the English version is more important because you will be find the English version of your final exam. 我还讲英文，因为考试是英文主题。You must be learn the how to write down the English, some of the definition of the English versions by yourself. Okay, just a vacancy. In your question, I ask you how to answer the vacancy and the self-interditions, okay? So you must learn and draw it, do the exercise by yourself, okay? Whatever, just you don't just look aside. Okay, you must write down and draw it. And the point defect, concentration of the point defect can be affected by the two parameters. The first one is the activation energy, and then you need to know what is called the activation energy. And the second parameter is the temperature. Okay, so you know that activation energy and temperature can affect the point defect, number of the point defect, or we call the concentration of the point defect of the material. Okay, and this is a very classical problem. Okay, you need to know how to calculate. If I give you some parameter and you need to write down the formula by yourself. Okay, in your final quiz, I can get you the formula. You must be remembered by yourself. Okay, 那个考试的时候我不会给你公式，我只会给你上面这4个参数，你要自己把答案凑出来，可以吗 ？Okay. And the ceramics, we know that what is called the ceramic. The ceramic is combined with the anion and anion together. They cause the ceramic material. They also perform different types of the point defect. Okay, they also exist the vacancy and the interdiction. Otherwise, there are three special defects called the anion interdiction and the anion vacancy and the canon vacancy. Okay, you must be remembered what is the difference between these three types of the point defect in ceramic material. Okay, this is another two important defect types in ceramics. It's called Frankel defect, Sharpie defect. Okay, I think so. This you need to clearly understand the difference between the Sharpie defect and Frankel defect. Okay, 这些 defect 你要很清楚，因为我考选择题的时候，你要选出正确答案。我可能给你个描述，问你说现在这个描述的情形，它是 Sharpie defect 还是 Frankel defect， 或是 vacancy， 或是 interdiction vacancy 等等，就给你出了4个选项来回答一样。你要自己确认哦，定义。原则上 ，material science 定义 definition of the material science is very important because the clearly definition can help you to get the right choice in your elective question. Okay, so what is called substitutional solid solution, and what is called interstitial solid solution. And the condition of the substitutional solid solution, okay, I think you need to understand, is how to find the substitutional solid solution is because the material must to maintain the flowing condition together, and it will form the substitutional solid solution. Okay. And what is called the electron neutrality property in ceramic material. Okay. And what is called weight percent, atomic percent, some very simple explanation about the concentration or composition of the solid state solution. Okay, the light defect. Okay, the light defect, I think the dislocation is called the light defect. What kinds of light defect? And the dislocation can affect the material straining mechanism, right? We have been talked about in our next chapter. So what they call dislocation. And dislocation can be defined as 2 types. We call the linear defect. Okay, A dislocation and the screw dislocation. It can be spin and the translation. Okay, the 2 types of the dislocation. Okay, what is called the edge dislocation? Okay, where is the edge dislocation in these samples? Okay, we know that in this sample is represented as the dislocation line exists in the lower plane. Okay. Okay, the VMSD is you can help you to observe, do the observations of the screw dislocation and the edge dislocation, and also the mixed together property together as the mixed dislocation. Okay. Imperfection is all this. Okay. And okay, I think this is very important. Okay, it tells you why the SCPs are more vital than the FCC and the BCC. Okay, it's because maybe I will talk about this problem in the following chapter. And the plan defect. Okay, I think it's a very straightforward. It's a train boundary. What is called train boundary? And what they call the catalyst, the 催化剂. I think the surface defect can be seen as one kind of the catalyst. Okay. So it's because it can be seen as a chemical reactive point, can affect and can do activity, chemical reactions with our environment surrounding material. Okay. So the catalyst and the surface defect. Okay, the optical microstructure. Okay, how does the can we see of the optical microscope? So optical microscope can be seen as why we use the optical microscope and find the black region and the light region. Okay, what happened between the black region and the white region when we're using the optical microscope? You must be understand. It's because the scattering is the main factor to affect our results. Okay. Okay, STM. Okay, next chapter. Okay, diffusion. I think diffusion has also some of the classification. The vacancy diffusion, interstitial diffusion, and what is called the vacancy diffusion, you must be drawn by yourself. Okay, what is called the vacancy diffusion? Okay, and what is called the interstitial diffusion? Okay, what is called the interstitial diffusion? And there is self-diffusion, the third kind of diffusion type, self-diffusion. And the first one, we talk about the self-diffusion. Okay, the steady state diffusion. Okay, you must write down the formula and the parameter just like our quest 2. Okay. And this is called the fixed first law. What is called the fixed first law? To tell us what happened about this experiment. Okay. So you need to understand how to use the experiment result to explain the fixed first law. Okay, it's a very simple example. If I give you some parameter, you must to give the answer. Okay. Okay, the J, the fixed first law, is related to this equation, and you must insert the 4 parameter into this formula that gets the answer. Okay. Non-steady state. Okay, what is called a non-steady state? It means the diffusion flux concentration gradient varies with time. We call it non-steady state. And this is you would use the fixed second law to solve the non-steady state diffusion problems. Okay. And also you must remember the meanings of each parameter by yourself. Then you will get some results. Okay. So this results to help you to understand the concentration vary with time, right? The same material, the same experimental sample, however, the time passing, the concentration gradient also change. Okay, so this is a most important result you must remember if the diffusion flux concentration must to vary with time. Okay. And the second one, I think is another important factor. Is the factor that influences the diffusion. So first one is diffusion species. Okay. If the impurity is large, it's hard to occurs the diffusion. However, if the impurity is smaller, like the exponential impurity, it will be easy to change the rates. Okay. Temperature. Okay, the temperature is another important factor that causes the diffusion change. Okay, it follows the diffusion factor. Okay, the 2 parameters. And I think that this picture is the same with the previous page. Okay, we just focus on the temperature can affect the diffusion dramatically. Okay, we also told with the same concept. Okay, maybe I will give you this picture in your final exam, and then you can give me the answer which line is come from the interstitial impurity or the substitutional impurity. And maybe I can give you 2 lines, and then you need to insert the right combinations for this picture. Okay， 就是我考试的时候可能给你这张图哦，然后给你把这些材料挖掉，叫你填。哪 A B C D E 对不对？哪一条线的趋势最有可能是 substitutional 的 impurity 的 diffusion？ 为什么？哎，你一看就知道是什么，当然就这一条啊，对不对？为什么？因为它的扩散速度是最慢的啦，最难发生的扩散。如果你要看懂这些图，我考试的时候可能会，期末考的时候。除了叫你们画图之外，我也会在选择题里面出很多图，让你们看过，可以吗？比起考定义，你要看懂图到底要给你们这些什么概念，这个是更重要的。OK， I think that in your final exams, I will give you some pictures in your elective problem, and moreover, I will ask you please help me to draw the answers in your Q&A problems. So how to draw and understand the picture's meaning in the material science is very important. Okay. Okay, so I think the index page is such a very important. It's a mechanical property of the metal. Okay. So this is a mechanical property. You must remember the definition. Okay. Particle strength, elasticity, plasticity, toughness, and ductility. I think that we have been write the problem is about your class 2. Okay, tensile strength, shear strength, simple tensile strength, and the lateral strength and the shear strength. Okay, I think it's just like our today's question answers. And also, you need to understand write down this the picture. The picture must be followed maybe the 4 or 5 steps. Okay. The first type is elastic, plastic. Okay, sorry. This one. Okay. Elastic for the Young's module, proportional limit, yield strength, tensile strength, and resilience. Okay, I think so. I have been do the discussion about this property in our previous course. So you need to write down, and then you know what is called the plastic deformation. If I ask you, please draw the picture and give the explanation about the plastic deformation. Okay, I recommend you to write down this picture and then do the explanation by yourself, and then you can get the 100% scores in this problem. Okay? 可以吗？就是待会画图，那我图很简单，就请你画一下，请解释一下什么叫塑性变形，请你画一下，那最好就把这个图画一下，可以吗？继续，压水，压水 ，tensile strength, toughness, resilience, ductility. Okay. What is called the true strength and the true strength? The difference between the true strength and the engineering strength, it depends on on the area. The button area would be changed, okay, if we do the true stress and the straight. Okay. However, for the ideal or engineering stress, the button area is not changed value, it's a fixed value. The hardness, how do we do the hardness test? Okay, what is the Bonnell and the Knuth and the Vickers hardness test machine? Okay, what the difference between the Rockwell and the Bonnell? Okay, I think the shape and the sample size are different. Okay, usually the Vickers and the Knuth can do a very small or even microstructure of the hardness test, and the Knuth and the Rockwell is usually use a size much larger. Okay, you can see the Rockwell hardness test is more than 60 kilogram, 100 kilogram, and 150 gram. I think it's large. Okay. Okay, this is summary. I think you need to learn by yourself. Okay, the dislocation. Okay, I think the main concept is how to increasing the material strengthening parameter. I think the most important thing is if we can restrict the dislocation motion, then we can make the material more stronger and harder, right? So we not to be increase the number of dislocation, we just restricting the dislocation motion. Is a core concept when we do the application of the increasing the strengthening property of the material. Okay. Okay, what we call the slip. How the slip operate the material, and usually without any restricting condition, the slip usually dislocation like to be shift and move its position to the outer surface. Okay. So if we can restrict this motion, then we can increase the strengthening mechanism of the material. Dislocation motion. Okay. Okay. The dislocation can do the interaction by itself. Okay. So why? It's because due to the strength field difference. Okay. If the two dislocation is located in the opposite side, they must be eliminated finally if they meet together. And otherwise, if the two material or two dislocation located in the same direction, they will be shown as a dramatic repulsive force. Okay. This calls the okay, and in this one is called the slip system. The slip system is make the material easy to oppose the motion. Okay, they must be maintain the two conditions. Okay, in this system, they maintain the slip plane plus the slip direction. Okay. Otherwise, we can say that we must find the slip plane first. Then we can, based on the slip plane, we can find the slip direction second. Okay, so what we call slip plane? Slip plane is the highest plane density. Then if we can find the highest plane density, then we can continue to base on this highest plane density to find the highest linear density. So the slip direction, the dislocation motion is usually occur in such direction. Okay. So this picture that tell you why the HCP are more brittle than the FCC and BCC. It's because for the HCP, whatever the two types of the different structure, they also usually perform only 6 slip system and only 3 slip system in the HCP crystalline material. However, the FCC or BCC material, they usually perform the more than 12 slip system. So that's why the HCP are more brittle than other two structures. Okay, so we continue to talk about the reverse shear stress. Okay. So this stress can tell us why we apply the tensile stress, and the slip is usually along the specific direction. Okay. not the opposite or parallel direction. Okay, in our result, we can understand if we do the tensile strength of the material, the usually occur the larger tensile stress or reversible stress is above the 45 degree. Okay, so that's why we can find if we apply the stress, the state plan is a 45 degree, ideally. Okay, then without the perpendicular with the tensile stress area direction, or even if they without the parallels with the tensile stress direction. Okay, how to increasing the strength in material? Okay, you must be follow the three concepts. The first one, the grain size reduction, and the solid state straining, and the shear head, all called co-worker. Okay, we just backward to change the shape strength into the material. That will be increasing the straining handling mechanism of the material. What they call reducing grain size. Okay, why? And how do we get more smaller grain size? Very easily, we just increase the highly rate of the solidification process. Okay, you can get a smaller grain size. And the second one is solid solution straining. Solid solution straining means that we add the impurity, whatever the larger impurity or smaller impurity. Okay, you must be learn by yourself, review by yourself. Strain handling is in the ductile metal becomes stronger when it's plastic deformation. Okay, we just backward change their shape, and finally we're increasing the straining mechanism of the material. How to recover it? Okay, how head treatment would be covered the three things: recovery, recrystallization, and regrowth. You must be remember how the hard treatment can be recovering the material's property. Okay, the important thing is the recovery and the recrystallization and the grain growth. Okay, hard working or the co-working. And the co-working means that the material occurs the deformation below the room temperature. Or hard working means the material occurs the deformation above the room temperature. Okay. Okay, failure. I think so. Failure cause a ductile fracture, brittle fracture, and on the regular ductile, I think you need to know the shape between the various type. And why the ductile failure after the broken? Okay, it must be after the large deformation, and the brittle value is usually after the small deformation, okay, like the ceramics material or glass. Failure stage, they are show you the 5 stages when the fault is observed in your inner air material. Then finally will be find the failures. Brittles, fractures, they have show us 2 types of fracture: intergranular and transgranular. Okay, the structure, stress concentration, you must be remembered, and we have been taught it today, right? Today we taught more than 2 twice what is called stress concentration. Okay, and what is called impact testing, and what is called DPTT. How the DPTT transition temperature affects our application. Stress circle. Okay, what is called the average stress, range of stress, and the stress amplitude, and the stress ratios, and the reverse stress circle, and the repeat stress circle, and the random stress circle. And what is called protect. Okay. Usually, point of protect. Okay. And why the 90% of mechanical engineering failures are due to the fatigue limits. And what they call the fatigue limit material and without non-fatigue limit material. You can do the very clear explanation how these two types of material affects the application. Okay, the quick propagation. How to prevent the how to extend the fatigue life. Okay, how to do the surface treatment. And what is called quick? Okay. Okay, I think the phase cycle. We just stop at our today's results. Okay, the phase. What we call phase? What it calls the solubility limit. Okay. Okay. If I post the picture, then you can answer the question or not. Okay, you must be learn how to answer the question according to the best cycle. And what is this microstructure tells us? Okay, you can answer how many phases in this picture. Okay. Okay, this is the okay. We know that the temperature can change the number of phases. Okay, whatever the A to B or B to C. You must be step by step to observe. You use the phase diagram to answer the question. Okay, I think so. I think so. You must be see this problem in your final exam. Okay, what is called the two binary system? What is binary system? Okay, and what is some how to use this picture to answer the question, such as you can give me what is called the binary system, and what is called the isomorphous. And if we know the T and C, then we know which phase is present in a specific point, such as from point A to the point B, or question 2. If we know the T and C concentration, then we can determine the composition of each phase. Such as you can tell me what is the composition of the point A, and what is composition of the point D, and what is composition of the point B. Okay. And answer question 3. If we know the T and C, then can determine the weight of duration of each phase. How do we calculate and use the phase diagram to answer the following question by yourself? What is called the Lover's rule? Okay. And how the Lover's rule can prove the answer. Okay. This answer, how to use the Lover's rule to get the answer. And what is the coolings of the carbonical alloy? What happened about the microstructure? Okay. Well, I think so. We will start here, and in the following chapter contest, we will use the online video. You must be learned after in the week 70 and in weeks 17 and week 18. Okay, there I have a bonus scores. Okay. Okay, I think I need to emphasize. If I post the final score in your portal system, that's not to modify the score. Okay, it just only to check the calculation, the sum of the score is right or not. But you can modify any point of the score. 好，就跟大家讲一件事情，所有的加分作业，所有的成绩都是要准时的交。那总成绩在你们的系统出来之后，是不可能再修改的。修改的地方只有一种可能，就是加错分数，它没有办法再去调分数，可以吗？意思就是说，如果你55分被我当掉了，你也不用来找我说，老师55分可不可以让我加分加到60分？不能，可以吗？就是我没有办法再去做调分这件事情。当我总成绩已经公告出来的时候 ，OK， 它只能去做一个有没有加法跟减法，有没有乘法跟除法，有没有分数的加减错误而已，以及每个人都可以去知道它的细项分数，可以吗？可是，比如说你的成绩，比如说报告成绩 ，if you get the report score is 83, so you can you don't ask me why you give me the 83, why do you give me the 90, then I can pass the material science. I said no, you cannot modify your score. Okay, so why I need to emphasize again is because you have time to do a thread about your material science. Okay, okay. You cannot modify the score after I post your final score. OK， 可以吗？就是我在这边强调一件事情的原因，就是因为第一个就是我希望你们现在还有可以努力的空间、时间的时候，你们一定要把握，好不好？所有成绩出来之后，分数是不能调整的，所以你找我跟找助教都没有用，可以吗？可以哈。所以你们要努力的就是第一个，刚刚加分作业你一定要交，然后第二个就是你一定有什么要跟大家讲一件事情，17跟第18周的 self learning report is a very very important。有些人去年写超认真，服务课我讲服务课，写超认真，写90几分，也有些人 OK 写60分，那个分数会差很多。I think the final self-learning report is very important. Okay, maybe some of a student they give me the more than 6 page or more than 2 page to answer the one problem. Otherwise, have a student give only 1 sentence to answer the one problem. So do you think about the score difference? Okay, I just give you the 100% and the 100 scores and a point and the 50 points about these two kinds of the student. OK， 就是说呢，有些人去年回答问题，我去年不是写那个上学期写那学习单嘛？有人一个问题写了2页，而且手写。可是有些人一句话，一题只写了1句话，那你觉得我要给他几分？有些人说老师我交作业，为什么要给我这么低的分数？我说可是有人就写超认真的，可以吗？所以呢，最后呢，你说那个写1句话一定很懊悔，说老师我会多写一点。我说你又没有跟我讲说期末成绩这么重，期末报告这么重要，百分比已经秀在 POTO 上面给你们看的，你们那15%的分数你们不好好认真努力拿，我也没办法。什么叫做没有跟你讲过？我现在跟你讲。好不好？所以就是说，你们可以努力的时候，你们一定要花一些时间努力，好不好？17、18周到自主学周不是 summer vacation，OK？ The week 17 and the week 18 is a self-learning week, not the summer vacation. Okay, you just regularly to learning by yourself and find the suitable time, and then your free time. Okay. 那我们今天讲到这里，那有问题的再留下来。关于不懂的地方，不要跟我讲成绩，成绩